All attendees are in listen-only mode.
Hi everyone, welcome to the 3D Systems webinar using sub-D with Geomagic Freeform Plus. My name's Dave. I work on the Geomagic Solutions team. I'm going to show you some demonstrations on how to use subdivisional modeling, which is sub-D, inside Freeform. So let's get started. Subdivision modeling is a polygon mesh modeling tool which basically allows you to edit a mesh object using a very small refined base cage to control it. I can show you really quickly how this is done inside Freeform. Actually, let me launch Freeform real quick. Thought I had it up. Oops. Oh wait, I do. So this here is a subdivisional model. You can see the base cage right here is the control object, and the orange model underneath is what we're going to be ultimately affecting. So if I come over here, I can touch the surface and move it and manipulate it, and everything is transferred down to the model underneath. The power of this gives you the ability to work on a very simple object and have something underneath that you can divide, which if I show you here at a single level of division, this face right here only divided once shows 4 separate individual polygons. But at any point during the design, I can change the resolution so I can get a better preview of what I'm working on. And if resources get a little low, I can always dial back the resolution and continue working at a very fast pace. Now, this is very different from the way clay voxel modeling works, where if you're familiar with Freeform, the voxel resolution is based off of the smallest level of division that you're going to use for your voxel object. This here is a low-resolution clay object, so you can see it's very rounded on the edges, but it does have very flat, smooth edges. Even when you raise the resolution quite a bit, you still have a little bit of softening in there, but it gives you a much finer, better surface to sculpt and to add detail. That there is where Freeform's power really lies. We have been using voxel modeling for many years, and it's unparalleled with what you can do. But when it gets to large models, like this one here is about, I think, 15 or 20 million polygons between all the separate objects, it becomes very difficult to manipulate. You have to hide and show and do things like that in order to continue working on parts of the model. Sub-D, on the other hand, would allow you to lower the resolution, continue working, and be able to move freely through the model while still being able to see everything. Voxel modeling in clay also only gives you a single layer of symmetry. So you can pretty much mirror across one flat plane. Now, subdivision modeling, sub-D, gives you the ability to change resolution on the fly, like I had mentioned. We can also very easily define sharpness and creasing on the model. So if I come over here back to the model, you can see that this object right here looks very rounded because the algorithm that defines the shape underneath tries to smooth everything out. If I select an edge right here and change my creasing, you can see that that edge right there tries to crease to somewhat mimic the edge of that cage. Likewise, if I take a couple edges over here and sharpen them, you can see that it stretches out to meet the bounds of the cage. I will actually also select this one here. And if I turn off the control cage, you can see that we have very extremely sharp edges, and because this is a polygon model, these are retained throughout the process, and when you go to export, either to mesh or you can go to solid, all of these sharp edges are retained. That is crucial for other parts of manufacturing. SubD does give you the ability to use lower resources. This model over here that we're looking at is a dragon that the base cage is about 3,000 polygons, while the subdivided mesh underneath is somewhere in the realm of 2 to 5 million. I can edit this quite rapidly and still work the same way I normally do with all of my other SubD tools. And if I needed to, I can always down-res the mesh and continue working if things did slow down. That is a huge time saver when you're working on large models or very complex objects. We also offer multiple types of symmetry when working with SubD objects. You can see here, this here is radial symmetry, so it's across all of these faces. We also have planar and multiple types of planar symmetry, so you can do X, Y, Y, Z, and have them all interact with the model at the same time. This here speeds things up because what would have taken time to create a small slice and duplicate and rotate, now you can do all in one operation without having to worry about any of the downstream effects. Now, throughout the course of this demonstration, if you have any questions, please log them in the GoToMeeting window. We're going to collect those, so at the end we're going to do a question and answer session. We will also do a couple survey questions throughout, so please keep your eyes peeled for those. Right now I'm going to hop straight into a demonstration. This model right here, this dagger, is actually completely made out of SubD surfaces. It's made out of 5 of them. The blade, the cross guard, the handle, the claw, and the ball are all individual objects. And these are all just right now linked together. And I'm going to show you how to make each of these parts in the next about half hour or so. So actually I'm going to hide this and bring up my initial sketch, and let's get started. So first we start with a generic SubD object. This here, it always imports as a cube. So what I'm going to do is I'm going to adjust the scale of it. I'm going to bring this down to about 15. The first object I'm going to make is the cross guard. So I'm just going to try to shape this to roughly those proportions before I go in and before I start editing by hand. So I think now about 30 in the Y direction and about 20 in Z. If I rotate around, you can see that I squished it that way as well. And because this here is a symmetric object, I'm going to add symmetry in the Z direction, so I don't have to worry about manipulating everything equally across the bounds. And you can see a plane showed up to show that. So now I'll enter my editing tool, select my object, and I get my cage. So I just start by selecting the vertices that make the edge that show the edge of this. Move this over. Actually, let me turn on my axis guide so I move planar. Move this roughly in place. And I'm going to turn on see-through. So I have to show this in my utilities because we have a whole bunch of tools that are familiar. If you're familiar with polygon modeling, a lot of what I show you today will seem at home. So I'm going to turn on see-through and actually turn up the transparency a little bit. Okay, now we can see the plane behind it. So to begin, I'm going to cut in the back face of this object. So I'm just going to rotate around and select this face, and I'm going to use what we call the Add Face Loop tool. So with that face selected, I click it, and we cut in a new face that's linked to the original outside face. And I'm also going to scale this a little bit, because right now that would be a really thick edge. So using grow and shrink, I can scale by a factor of the percentage that's shown right here. So I'm going to scale this down a little bit. And now I'm going to extrude this face inward. So clicking extrude, I then touch the face and push in with my haptic device. So now I've created new geometry, and you can see that it's a very rounded edge. That's not going to work very well for this sword handle, so I'm going to go back into my selection tool and select and select a loop, which is this area right here, as well as the outside loop, holding Control and select the loop again, I'm going to crease this edge to sharpen it up. So I slide this, and you can see that dynamically I can edit the sharpness and the amount of detail on that edge right there. If I crank this up all the way, it will be perfectly sharp. That looks pretty good to me. So now I'm going to go back into my side view and turn back on the plane, go into see-through, and we can see that we're a bit off from the initial size that we were looking for. So that's easy enough to fix. If I select some vertices, start pushing and pulling. This here is very common with polygon editing. You end up working on the vertex level frequently. So I'm going to roughly line this up with the shape. And now take this outside one here, drag it back, and you can see that the inside face would be a little close, so I'm going to give a little bit of distance in there. Same on this side. And now we have something that closely resembles the shape that we were looking for. Well, this is a little off, so I'll just tug this up a tiny bit. I'm going to hide the plane again real quick and rotate. And it looks a bit like a tortoise shell, so I'm going to shape this a little bit. Since we have the symmetry turned on and it's along this plane right here, if I adjust this side, the other side will match. So I'm going to go back to my side view. And I'm going to cut in a little more geometry so the blade has a place to sit and the handle has a place to sit. So much like I did to do the initial inside, I'm going to add a face loop here on the top. And I want to scale this face, but I only want to scale it in one direction. So I will select edges that define the direction I want to scale it in, and using the scale again, I will shrink it down, and we're only scaling along the x-axis. So if I turn back on my plane real quick and rotate, we can see that this still is a little bit tall, so I can scale it in the y direction. And move it up a little bit so it's in line with where the blade's going to sit. Turn back off my reference and do the same type of operation here on the inside. So I just select that internal face. And this one here I'm just going to extrude out. So we have a little bit of a room for the handle to meet the inside of the handguard. We also have keyboard shortcuts for a lot of these things here, so using the plus and minus keys I can adjust the scale. And then if I do a selection, crease this up, do the same on the outside, I will select this, make an extrusion, select the edges I want to crease. And right there, let me click off of this and turn back on my background plane. We have a really good representation of the sword cross handle that we want to make. I'm going to move on from here just to keep the demonstration going. I can add small details, I can cut in more geometry, but that there is all just part of the design workflow. This sword originally took me a little over an hour to do, and I'm trying to limit this in time, so instead we're going to move on. I'm not going to show the finished part right now. Instead I'm just going to go to the next section, which is making the sword blade. So this here is a much more complicated piece. So what I'm going to do is start from this object right here, and I'm going to lay down the points that define the edge of this blade. So let me actually hide the toolbox so I have a little more space, and I'll click right here. I'm touching the plane, so I'm on the center line, and wherever I want an edge to appear in my model, I just click, So I'm going to trace a somewhat rough curve and match them across the blade. Subdivisional modeling is best kept to four-sided faces. So whenever possible, try to make four-sided faces while you're working with this. It makes the underlying mesh more predictable. It also makes for clean exporting and working with other objects later. So now I close this up, and that's a little ugly at the moment because I haven't cut back in the geometry. I just have to go into my options palette real quick and show my vertices. And I'm going to use the Add Edge tool, and I'm just going to cut across from one side to the other. I know this is not the most interesting part of the demonstration, but at least it's quick. And the flexibility this gives me later, having well laid out geometry, is well worth the 30 seconds that just took. So I'm going to select this object, enter my extrude tool, just click one face and then do Control-A to select all of them. And from here, I'm just going to rotate to the side, hide my background plane real quick, and extrude this out. So this could have been done using Wirecut, this could have been done using a multitude of other tools in Clay, but we have the ability to go in, refine, sharpen, and do all sorts of other things with this object afterwards that might not have been as easy. So I'm going to use now my Add Loop tool to cut a single loop that goes down the center of this object. So I have something to define the blade edge. And because I want this to be symmetrical, I can add symmetry after the fact and define any number of symmetries after the fact by selecting vertices that define which plane I want it to cross. So it'll be dividing between here. And then I can go to my symmetry palette, add planar, and a new plane shows up. So now if I select this right here, you can see my object is now symmetrical across that line. So, with this part done, actually I need to move this object over just slightly because it was drawn on top of the plane instead of splitting the plane. So I will go right here, go into reposition, and just translate this across Z a little bit. There we go. Perfect. Yes, I want to apply. Hop back into my side view and turn this on see-through. There's a really nice blade detail that runs down the edge of the blade. So what I'm going to do now is I'm just going to add a little more geometry so I can capture that. Going back into my Add Edge, start right here, and just cut along the edge of the blade, cutting in between, misclick. This here will define this nice groove. Bring that all the way up to the tip and cut in from here to capture this. So what we have now is a fairly well organized but still a little bit squishy looking knife blade. I'm going to turn off the transparency. So now what I'm going to do is I'm going to select edges and add sharpness to them. So if I select this one right here and pick a loop, it goes almost all the way around the blade. I'll just add right there and continue the loop and crease that up. So now we actually have a nice solid edge that goes around the blade, and I'm going to do the same for the one that runs down the center. And crease that. That doesn't show anything visible at the moment, but what happens when I come over here and start manipulating these points, so if I move this inward, drag it up a little bit, so I'm leaving the center line alone, that's going to define the edge of the blade, and these ones here are going to show the sharpening edge, and I just drag them up. If I rotate around a little bit, you can see that we've maintained a nice sharp edge, and we're actually giving detailing along where the blade would have been honed to sharpen it. And I can change the amount of this any place I like, so it looks like it was gouged in a little more there. Down here where it becomes a bit fatter and a bit more solid towards the handle, I can leave that alone. And then from here, what I'll do is manually select the line that runs along the edge of the blade. And crease that as well. So if I click off of this and rotate around a little bit, you can see that we have a lot of detail cut into that really quickly that is also very quick to edit. So a small amount of work going into this will result in a lot more flexibility later when you want to make changes to it, when something doesn't look right. You don't have to rebuild it. You can just grab a couple points, pull them out, and move on from there. I will also fix this real quick. The back edge being rounded isn't ideal. So just let me zoom in. Oop, not that edge. And sharpen this. There we go. Now we have a nice flat back. And of course I would want to make the dagger a little bit skinnier, add other flourishes on it, but you can see from this, in a very short amount of time, I added a lot of detail and still giving you flexibility to make any type of changes you want throughout the design process. I think right now is a great time to do the first of the poll questions for the users. So I will pass that over right now. Okay. Thank you all. So we have this much done already in this little amount of time. So from here, actually I will hide the blade I just made and open up the finished one because it looks a little better. What I'm going to do next, if we bring up the image plane again, is this handle. Now I like the way this handle looks, but it doesn't look like it would feel very good in your hand. Iterative way design works, the way things evolve, I want to make a change to this. I want to make something that looks more like wrapped leather. So from here I'm going to actually just going to rename this so I don't get lost. I'm going to create a new sub-D object, and I'm going to make this one here longer in X, so I'm going to make this about 50, shrink it down in Y about 15, and 15 in Z because we want it to be roughly the same proportion around. Actually, I might make it a little smaller. We'll go 10 around in both of these directions. Perfect. So now, take this. I'm going to hide the other blade, hide the crossguard, and move this into position to cover my handle. And actually that is a little bit long, so real easy to fix. What I'll do is I just move around a little bit, take this face, and drag it back. Same could be done for the back. And because I'm using the haptic device, I can feel exactly what I'm doing, so I don't even have to be looking at it, which is a big advantage that saves time on having to move around. Perfect. Now this is not going to be a symmetrical object. Instead I'm going to do all of this by hand, so I'm going to start by adding in an edge loop, which we saw during the knife how I cut down the center. I'm going to break this into 4 separate pieces. So I'm going to break it once in half and then in quarters. from here, I want to make the detail of what is going to look like wrapped leather that goes around the handle. So I'm going to hide the back plane and just cut in the geometry that I want. I'm showing one strip at a time, but all of these cuts could be done at the same time. You'll see in just a moment. Just rotate around a little bit. And I am just truly going from corner to corner. And with that in there, I'm going to remove the horizontal sections because those are not needed. So now that I have that part done, I'm going to show you what it's going to look like to create one strip. So entering my extrude tool, I will select the faces that I just prepared. Go around. And now what I'm going to do is I'm just going to extrude these out from the surface, creating new geometry. And I'm going to crease them a little bit to define the edges a little bit. And you can see if I deselect this that we have a nice wrap. It wouldn't take me much more time if I were to cut all the detail in one pass. So what I'll do is I will show you what the finished product would look like, and that is this. This here was done using that exact technique, and then just afterwards selecting the edges and scaling them up, and selecting the back, scaling it down, and extruding it out. And of course you can change the color of any of these objects very easily. So this one here, what is brown, I could make it orange or dark red. That doesn't show very well on screen, so I'm going to change that back to brown. So now we have a blade, we have the crossguard, and we have a handle. All of this was done relatively quickly, and it maintains a high level of detail. So what I'm going to do for the last step, go back into my side view, turn on my image plane. I'm going to create a stone to match the back of this. So new, 15, not 51. And that's still a little too big, so I'm going to shrink this back down to 10. Again, showing how easy this is to dynamically update. I can enter these on the fly, and now that I've got that new object in there, I'm going to reposition it. So I'm going to zoom in a little bit, turn on my snapping guide, and slide it back into place. You think that looks good? Think that would be done? No, I don't either. As you can see that we've already had the stone in there, and from the first demonstration you saw that there was a bit more detail in here. There's actually a whole claw that holds that stone. I can do this claw in a relatively short amount of time compared to what it would take using other design methods. So I'm going to hide the parts that I'm not using again. And this time here, I'm going to start by duplicating this. So I'll get out of reposition. So I will copy this and then paste it. Change this to claw and just reposition it slightly. Just to keep things straight, we'll call this stone, and I'm going to change the color of this. Make this a nice bright red. Perfect. So the claw, now that we have a reference for what the stone's going to be, I'm going to select this, enter my editing tool, and start by squishing it down. And from here, cut the basic shape of, just break it into fourths. And I had mentioned radial symmetry earlier. So we've seen planar symmetry. Now I'm going to add radial symmetry. So this way here I can model one finger and it will duplicate across the other four automatically for me. So I enter select, pick the vertices on the corners, and add radial symmetry. Those are the planes that define the symmetry. So if I turn around here, click and drag, you can see that they automatically update. Undo that real quick. So we start by extruding out individual faces. With this set to a scale factor of 100, this would just scale everything out as you've already seen where it comes out as a single face. If I knock this down slightly and make sure that I'm not fusing adjacent faces, when I click on this, pull it out slightly, you can see that now there are 4 individual faces that pop out, which I can then shrink down in size, bump this up a little bit, and if I rotate around to the back, we don't want them directly underneath, so I will just take those and start sliding these outward. And if you look, that's pretty well sitting on there. So now I will put this back up to 100 and extrude out a little more to define part of the finger. And at this point here, I'm going to rotate to start making it curve around the sphere. So using rotation based off of a screen view, I can rotate this, just pick a face and start turning it inward. Now, what I'm going to do is take this face right here, cut in a little bit of geometry using the add face, which we've seen before, and crease this. This here is going to give the division between where the finger ends and the claw begins. So if I extrude from here, you'll see that it's left with a sharp edge, and the new extrusion is also sharp. We don't want sharpness on this end of it, so I'll just turn this down, and granted we get a small nubbly knob at the end, but I can fix that too. Very easily by just cutting in a tiny bit more geometry. I'll just cut across, and you can see it update across all of the other objects because of the symmetry. And now that I have a single point in the center, I can take that, drag that out, and sharpen that up. Don't want to go too far because we don't want it to extend all the way out. But in just a matter of a couple minutes now, I've shaped a fairly serviceable claw, and I have the ability to keep it perfectly symmetrical across all the fingers. So if I pull out the knuckle, if I come over here and start editing on the inside because I can see the geometry, if I want to reshape the claw a little bit, I can make all of these adjustments and keeping perfect symmetry across everything so I don't have to duplicate my efforts. I'm also going to really quick round this backside out a little bit and go into my side view, select all of these vertices, and I want these nice and flat so they can butt up against the handle. We have a tool for that, so I can click planar points and it flattens them back out. And if I extrude and add a little bit of creasing, a little bit of sharpness on that, we actually have a nice flat edge that should fit pretty well with the handle that we've created if I had had the handle up. But this is not a problem. If I go back into my side view, what I can do is manipulate these points. From here, what I want to do is I want to turn symmetry off because if I grab a point, it's going to try to manipulate it around. So at any point, I can turn this off and now move these as a group. And these as well. Misclick. Shrink these down. Up a tiny bit. Move it into place. And there we go. Now part of the power of what you get out of sub-D that I have yet to mention is this object right here. We'll take a look at the claw specifically. Right now it's a sub-D object. It's very easy to convert this if I wanted to bring this over to mesh for export or turn it into a solid. If I turn this into a solid right now, it takes just a moment, and you have a very nice looking solid with very predictably laid out patches. If I undo that, I can also move this to clay really quick. So if I go to Add Fine Detail, create a new clay piece, you can see a little bit of the faceting on the face of this, and that was my fault, because when you go to convert the surface resolution, which is only divided down to where this is showing 24,000 faces, I can dynamically change this at the time of export to refine the surface, so I don't have to work with all those polygons while I'm working. So now I can change this, drop this down to clay, and continue working with any of the tools that I would normally use for clay sculpting or any type of voxel operations on it. So I think right now is probably another good time for a survey question. I only have another couple quick demos to do after this, so we can hop over and do that. Okay. Now, the next demonstration I'm going to do is a lot shorter than this last one. So, if I open up my demonstration file, it's a tire. This here is clearly a tire for an all-terrain vehicle or a tractor or something like that that requires a lot of detail in the tread and very thick and heavy treads. This here is all completely modeled. This was not textured. That's a very common thing that people will do for digital content creation. They'll make a simple object and just apply a displacement or bump to it. But this here is absolutely fully made of geometry. Now, you might think that this would take a little while. What would you say if I could make this in less than 4 minutes? Don't believe me? Let's see if I can. So I'm just going to start from scratch. I'll start with an empty model. And this time here I'm going to use a ring primitive. I want roughly 20 millimeter diameter, 15 thickness, 20, and 20. So now create a new ring. There we go. Oh look, that already looks kind of like a tire. So I'm going to hop into my edit tool, select this edge, create a loop, and add radial symmetry. This object already had 2 types of symmetry on it, so I'm going to turn off one of them because I do not want it to be symmetric across the XZ plane. So I'm going to turn that off. I'm going to increase the level of resolution on my cage and promote that so I can edit that. And now what I'm going to do is I'm going to come around here. I'm going to select this edge, and I'm going to just slide these along the surface. There we go. We already have some of the detail we're looking for. I'm going to hop back into my side view, come over here, and just flatten these out a little bit so it looks like it would something that would be actually driving on a surface instead of really, really deep treads. That ought to do. Now the power of the symmetry that I have enabled, if I go into my extrusion tool, I can select this face, this one right here, and this right here, and just this small action should cut in most of the treads when I pop in. There we go. That looks pretty good. If I step out real quick, it's a bit soft though. So if I click this, go back into my side view, and now I'm going to filter my selection, so I'm only selecting edges because I can choose between points, edges, and faces. Slide in here real quick and just make a broad selection so I get at least enough of one of the radial symmetry points. Now I'm going to increase my creasing, add a little bit of sharpness. This way here I do have some rounding on there and it's not perfectly sharp. And then what I'll do is I'll come over here and I will select this edge, mark it as a loop. I will tug this out, and then I will sharpen it up. Add a little bit of creasing to it as well. Deselect, back off. There you go. I don't even think that took me more than 3 minutes. Of course, from here I could go and cut sidewall detail. I can convert this to clay so we can do any other type of operations if we wanted to put text or name or anything on there. But that there is a really fast way to model something that is repetitive and has a decent amount of detail in it. And of course, you can see some of the faceting, so if I select this and just bump up the resolution a little bit, this model cleans up very quickly. The last demonstration I'm going to show you is a very quick way to go from sub-D to clay for other manipulations. So I'm going to open the dragon that we had seen during the slideshow. No, I don't want to save my tire. And this here, as I had mentioned, is all sub-D geometry. So if I take this and select this, you can see that we've got all those points. We have all of these faces. And I'm fairly happy with this. The power of making this model in sub-D to begin with is the fact that I can easily change the volume, I can change shape and pose without having to rebuild a lot of it that we would have to do using other methods. And once I'm happy with my base shape, we can take this and convert this to clay. We can go down to any other surface type that we want. So I'm going to make this 2 millimeters. Oh, wrong button. So custom 2 millimeter, because this is a very large model. I'm going to convert this to clay. And actually, you can see how quick that was. This is an extremely large model. This is about 1,300 millimeters across, and at this resolution, it's holding up quite well. I can go in and use my sculpting tools. I can add a little bit of detail. If I want to extend out the muscle from the top of the wing, and actually, right now, I have clay set on high quality, so it's a little too shiny. You can get a better idea of what I'm doing now if I turn this on. And I can also drastically change the shape of this. I can come over here, change the head. I can shrink the neck if I tug it back a little bit. And all these clay modifications, including the ability to emboss and detail the clay. So if I wanted to add something like scales to it, that's a very large scale, so I'll shrink that down a little bit, paint these on, and give a preview. 10 millimeters is way too much. So I could go through and update this model as you would if you're going to do any type of production, making a model. You can go in, you can paint, you can prep for mold making. All of the things that Freeform is legendary for, except you've now saved yourself some time with the initial model creation, and you have something that is very easy to edit. Say you wanted to make a couple different dragons, but you wanted to change the shape, you wanted to change the head, you can go in and make all the modifications on the sub-D model quickly, then convert it down to clay and everything else for the final preparation. So now I just have a few slides of demonstration models, and I can also show some other models. And we're going to do the question and answer section shortly. So I'm just going to hop back. Not right there. So this here is just a few examples of screenshots of other sub-D objects. This buggy was fully made out of sub-D. The dolphin, you can still see the cage. This bottle here was made using sub-D. The detailing was done in clay afterwards, which really shows the power of how you can create a beautiful shape, keeping all of the nice all the nice form that you want, and then go in and do all the flourishes, everything that you would like to do to finish your model. This toothbrush was made in sub-D and rendered out, and as you can see, it has a handful of pieces. It was fantastically made, and it was also very quick to make. Just the power of this tool is unbelievable, and I can't wait to see what users put this through now that they have a little more of a primer, because so far we haven't seen what this is really capable of besides what some of our internal workers have done with it. All right. Now, we can do an answering questions session. If anyone has questions that are, if anyone's given questions, we can take those right now.
So thank you, David, for the presentation. We do actually have a handful of questions here. So I'm going to get started right off the bat. Can you describe the difference between crease and sharpness again?
Okay, the difference between crease and sharpness. Sharpness is trying to extend the geometry all the way to the edge. So if I go back over here into Freeform really quick, and go to this model right here, rotate around, if I select this edge and I sharpen it, you can see that it is pulling every single face to fully meet the edge of the cage. Creasing is going to influence the model, so it's going to sharpen along that edge, but it's still going to try to keep some of the contour and smoothing that is defined by the algorithm. There are times where both are appropriate, and sometimes you really have to play to figure out which one looks better for you. But if you're trying to rigidly meet what the outside of your control cage looks like, you're going to use sharpening, where other times, and I find myself more frequently using creasing because it's a little more forgiving, and especially if you're working with organic shapes or flowing shapes, creasing is what you're going to use.
So next question. Can you make extrusions in the grow shrink function using values instead of a percentage scale?
Actually, we do have an inset offset. So what I can do is if I take my extrusion tool, click on the face, and if I extrude out just slightly, I can change the offset. If I hit 0, or actually 1 millimeter, I can offset by that amount. The initial extrusion, I should be able to extrude at 0, but I'm not sure why that popped out for me slightly at first. I know there's a way to do it, but right now it's just not behaving properly for me.
Okay. Next question would be, modeling a leather handle is easier, but how would you approach for a woven handle?
The woven handle would probably take a lot more effort. I would end up cutting in the geometry the same way that I made the knife handle, where starting in the side view I would lay down certain points to define the individual strips, extrude them, and then add them back together. We also can add textures to this, which I didn't get into in this demonstration, which if I select the sub D face, right now I have a displacement. I'll turn on displacement, and what we can do, actually, the scales are a really good representation of how this works. So if you had a texture that was already prepared for displacement, that was seamless in both X and Y, you can apply it to a face and continue applying them to other faces. So that's another approach that you could take to try to make a wrapped handle. I mean a woven handle, rather. And while I have this up here, I can also show you that since those are applied and those are not cut into the geometry, I can still edit the cage as I normally would, and they will stretch into form based off of the shape of the control object. So you can do an awful lot with textures, and I was saving that for a future demonstration or other webinar.
Let's say we need to design a part with a specific tolerance to mate to, for instance, a metal ball joint. Currently, the part was designed with SolidWorks. How could we make that part in sub D with a specific tolerance we can adjust when needed?
That is one of the shortcomings of sub-D modeling. It is a lot more difficult in order to meet specific tolerances. You can convert to clay, you can you can get a rough base object in there and then move to other types of geometry in order to meet what you're going to do, but it's not easy to do directly in sub-D.
Is it possible to develop a customized demo for a sneaker midsole outsole if I provide the artwork and my completed model created in Surfaces?
I believe we could.
Okay. I will, Steve Bruno, I will send you a separate response to that shortly as to how to get in touch.
Okay.
Using a program such as ZBrush, there lacks a way to measure objects and to establish good fit. So does Geomagic solve this by dividing the tasks and incorporating both?
We can measure off of these objects using the tools that Freeform provides. So our ruler tool does give us an ability to measure this object. Right now I'm just measuring thickness, going across things like, and we can do fit between this and other objects using the same tools that you would normally do with clay or mesh. As far as mating and things like that, it's still a lot of how it's designed and how close your tolerances are.
Can I turn a clay part into a sub-D part?
Unfortunately, no. It's a one-way street. You have to start with sub-D, and then you can go into the other geometry types.
Okay. Unless anyone has any other questions, we appreciate you taking some time this morning, this afternoon, this evening, depending on where you're located. Thanks again to David for an excellent presentation. There will be a recording of this along with some additional information about Freeform 2014 and in particular sub-D emailed to you over the next couple days, so please keep an eye out for that in your inbox. And again, we thank you very much and encourage you to visit geomagic.com for more information.